Welcome to the 44th session of LMS. Program is for BSc. Subject Mathematics, 5th semester. The title of the paper is Numerical Analysis. The topic that we are going to read is finite difference, in which today in this session we are going to know about the factorial notation or factorial functions. If we recap what we have read in the last sessions, is we have solved some of the problems on separation of symbols in the last sessions. At the end of this session, we can able to define what is mean by factorial notation, and we can represent a polynomial in factorial notation. So definition of this factorial notation: a factorial polynomial of n degree with unit interval 1, that is h is equals to 1. It is generally denoted by x factorial n, that is here it is, we can say how it is, this is there, we can see it here, x within the bracket that is written n, it is called as a x factorial n. And how it is defined? It is defined here, you can see it, x minus 1, x minus 2, dot up to. In particular, if n is equals to 1, then x will be there. If n is equals to 2, x factorial 2 is written by x into x minus 1. If x factorial 3 is there, then 3 terms will be there, x minus 1, x minus 2. Like this it will goes on. Right, friends? So if the interval of difference is h, that is we are taking h as the interval difference of h, then what will be the x factorial n? You can see it here, that is x factorial n is equals to x is one term, x minus h is another term, x minus 2h it should be. Like this it will goes on up to where x minus n minus 1 times of h. Right, friends? Right. Now in general, if we write this in general, it is nothing but an x factorial n is equals to x factorial n minus 1 into x minus n minus 1. Now if we want to find the forward difference of a x factorial m, right? That means we are now going to find the factorial for forward difference. What will be that one? Forward difference of this one. Now I can say here should be a forward difference. Okay. So what will be the forward difference of this? So forward difference of x factorial m, here it is, forward difference of x factorial m is equals to, we know that it is nothing but an f of x plus h minus f of x. It should be f of x plus 1 factorial m minus x factorial m it is. That is, I can say it should be x plus 1 factorial m minus x factorial m, like this. So brackets has been not displaying here, it should be with bracket, right? Okay, in this way we can represent where h is equals to 1, right? Now I will express this factorial notation, x plus 1 m factorial. What is its? X plus 1 x minus 1 dot up to x minus m minus 2. Right? This is my first factorials, that is x plus 1 factorial it is, right? Now this is my first factorial, that is this one, right? Now minus is there, minus I have kept it. Now x factorial m, we have to write that expression. Here is x minus 1, x minus 2 dot 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 up to x minus m minus 1 factorial. We have wrote it here, you can see it, right? Now in this 2, if you see in this 2, what we can take common? Here is x is there, x is there, x minus 1, x minus 1, x minus 2, x minus 2, like this up to x minus m minus 2 I can take as a common, right? We have taken it common. Now what will be left out in this part? In this part x plus 1 is left out. Here we have wrote it minus minus, and it will goes up to here, and last term will be left out. We have wrote it. If you simplify this, so x will be there, plus 1 minus x, plus x minus x will get cancels, minus of minus plus, plus into minus minus, 1 will get cancels, and the m, only m will be left out, right? So we have wrote it here, you can see x factorial, this term, whole term will become x to the power of m minus 1 factorial, and this term is m, we have wrote it here, right? Now next we can say it will becomes like this. Forward difference of a x factors m is equals to m into x to the power of m minus 1 factorial. Similarly, I can go for second forward difference, delta square of x factorial m. This delta can be written as delta into delta. So delta will keep as it is. What is this delta of x factorial m? Here it is m into x to the power of m minus 1 factorial. So we have wrote it. Now I will apply this delta to the x again. Again it will be m minus 1 into x to the power of m minus 2. Right? There will be two terms like this. So similarly I can say delta cube of x factorial. Forward difference, third forward difference of a x factorial m. It is like this. Okay. In general, I can write it as, that one as delta forward difference of m is and x factorial is given by this formula overall. That is nothing but an m factors. Here m is there, so we can write m factors. Okay. So the difference of the factorial polynomial similar to the rule of the differentiation. If you see that here, it just looks like a differentiation, right friends? So now we'll talk about this how to represent a polynomial of nth degree in factorial notation. By taking a polynomial, we'll find this. So here is f of x, that can be written as y of x. This is my polynomial, right? Now I can say that this is nothing but an e power x y naught, right? So what do you mean by e? 1 plus delta, x has been as it is. Now I will express this binomially. So this is expression, y naught has been kept as it is. Now if you multiply this inside, we will get this. Okay. So here is y naught, first term, and then delta of y naught, delta cube of y naught. At the similar this you can see x, x minus 1, x, x minus 2, x minus 3. It will goes on like this as we go on, right? So I can say it is nothing but an x factors 1, x factor 2, x factor 3, dot 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 dot. Okay. Now we can say y naught is written as like this, and we can say that this is after the substitution at the single point. This is function, therefore I can say f of y naught is f of 0, y of 0 is equals to f of 0. Delta of y naught is nothing but an delta of f of naught plus dot dot dot. We can write like this. If you simplify after substituting this delta square f of delta of f of 0, all the value substitution, we can get this type of equation, that is a naught x factors n plus a1 x to the power of n minus 1 plus dot dot up to an. What is this a naught, a1, all those things? this is the required expression. We know that these are all are the coefficients. A0, A1, we have wrote it here. A0, A1, A2, they all are the coefficients, which are the remainders when we obtain by dividing f of x by x, x minus 1, x minus 2 successively using synthetic divisions. So we can get this one by dividing the function by x, x minus 1, x minus 2 successively by using the synthetic division method. We can get it. Okay, so we'll see it. Some of the reference books are here, right? So thank you, friends.